Okay, so welcome you all in today's lecture, second lecture in the series of optical fiber, and the topic is basically that we are going to define what are the different components that are used in optical fiber communications and what is the operating window in which we are going to concentrate if we are talking about the optical fiber communications. So let's start. So before moving into detail about that, what are the different components that when they are combined to form optical fiber communication link, we have to first understand what are the different frequency spectrums that we are going to concentrate if we are talking about the optical fiber communications. So basically there are three frequency spectrum that we have to look into. First is your infrared band. So in that infrared band, the wavelength will vary from 700 nanometer to 1600 nanometer. In this complete range, we have to basically concentrate about 850 nanometer, 1300 nanometer, as well as the 1500 nanometer, 1550 nanometer. Why? Because we have already seen in our previous module of this lecture that about the history of attenuation. We saw that step by step how the attenuation are decreasing in different wavelength region. We saw that there are three windows in which we have to concentrate if we are talking about the optical fiber communication. The first was 850 nanometer. In that we saw that it was around 4.5 dB per kilometer attenuation that is arising. Then after that, various further purifications that is going on, that goes on in the material for fabrication of optical fiber. As a result of that, they have reduced the attenuation content or the magnitude of attenuate from 4.5 dB per kilometer to around around 0.6 something in the case of your 1300 nanometers. Further purification in the materials and various methods, they have reduced the attenuation to a level of around 0.2 dB per kilometer in a 1550 nanometer band, 1550 nanometer wavelength. So that's why in this infrared region we are basically have to concentrate on these three wavelength, 850, 1300 and 1550 nanometers. Although the attenuation that was seen in the case of 1550 nanometer was around 0.2 dB per kilometer, but at present the attenuations have been decreased to a further level, and in various research paper, if you just search for the various research paper that is going on in this optical fiber communication, you will see that the reduction in the attenuation has been reduced to a further level of around 0.12 dB per kilometer. Instead of a 0.2 dB per kilometer, it has reduced to a 0.12 dB per kilometers. So you can imagine how far we have gone in the case of attenuation, while attenuation of a signal while moving from a optical communications. So we have to basically concentrate on this infrared region. We have to concentrate on the infrared region because mostly the optical fiber going to operate in this infrared band. Whatever the resources, whatever the optical sources that you are having, as well as the amplifiers and detectors that we are having, we are going to only concentrate on this infrared regions. So apart from this infrared regions, we are having a visible spectrum. So what is the range of visible spectrum? It is around 390 to 770 nanometers. So this is also the reason in which you can use a your fiber communications. So here the problem is that in this regions the attenuation is quite large, so we have to use it only for a shorter distance. So if we are concentrating about the communications for a longer distance, then we have to move into the region of infrared regions. That is because we have seen that in the case of 1550 nanometer, if you are talking about the 1550 nanometer, the reduction, the attenuation was around 0.2 dB per kilometers. So if you are transmitting any information from a source to destination, obviously the first thing that is strike in your mind is that whatever the information that you are transmitting, it should be reached at the destination with a very low attenuations. So that's why you have to concentrate in the infrared region, that too in a 1550 nanometer wavelength. So apart from these two regions, we are having one more which is called as ultraviolet. So that ultraviolet region is basically a region that is having a range of wavelength from 10 to 390 nanometers. So in this band, what is happening? This is basically used in the medical areas. So the fiber losses as is quite high. So you can't use this ultraviolet spectrum for transmitting information to a larger distance. So you can it in the medical area, like in the process of endoscopy, we can use this spectrum. So this is all about what are the different frequency spectrum in which your optical fiber communication can work. We saw first is the infrared region, which actually we are going to concentrate on this region. So after that, we saw that we are having another frequency spectrum that we saw that is visible region. So after visible regions, we saw another that is the ultraviolet region. So if someone asks that what is the different frequency spectrum in optical fiber communication can take place, then you have to say that it's three regions. First is your infrared, then you are having visible regions, and finally you are having a ultraviolet region. So once we got the information about the frequency spectrum in which we have to operate, in which optical fiber communication can work, after that we can see what we have to see what are the different spectral band that are used in the case of your optical fiber communications. So first band is called as a original band, and also called by a also called by a name O band. Its wavelength range from around 1260 to 1360 nanometers. So this was very first spectrum or a first band used for a single mode fiber communications or a single mode fiber links. After this, the second band is the extended band, which is also called as a E band. The wavelength range from around 1360 to 1460 nanometer. So the next is your short band, also called as a S band, having a wavelength range from 1460 to 1530 nanometer. And here, basically a wavelength are shorter than the C band, but it is higher than the E band. So the next is your C band, that is also called by a name conventional band. The range of wavelength varies from 1530 to 1565 nanometer. So as we have already discussed that we are going to only mainly concentrate in the 1550 nanometer, because the amplifiers that is called as a erbium doped fiber amplifier is available in the 1550 nanometer range, 1550 nanometer. So whatever the information that we are going to transmit, we will only concentrate in the 1550 nanometer for a long haul communications. So this is the band that we have to concentrate, and everyone should be having the range of wavelength for a C band in his mind, because this is a quite frequently question that has been asked, that might be asked in different interviews or in different viva of optical fiber communications. So everyone have to remember all these wavelength range, especially the C band, S band and L band. So apart from this, we are having the next band, which is called as a long band, called by a short form as L band, and the range of wavelength is from 1565 to around 1625 range. So as this band is having, if we are using this L band, then in that case we have to avoid the use of EDFA, because the gain of EDFA decreases in this wavelength range, and which we don't want actually. Its gain should not decrease very drastically, because if the gain decreases very drastically, you won't be able to achieve your aim of increasing the amplitude of the signal. So the next and the last one is the ultra long band, and the wavelength range move from 1625 to 1675 nanometers, and this is the range which is beyond the scope of your EDFA. Now this is the main topic, I mean elements of fiber optic communications. What are the different elements that when they are combined, they will form an optical fiber link? So the first one, in every communication, in every mode of a communication, we know that what are the basic element of any mode of communication. First is it should be having a source, then second thing it should be having a channel, as well as the last thing it should be having a destination. In a broad way, we say that it should be having a transmitter, then a medium, and then finally a destination. So the same concept is used in this also, elements of a fiber optical link. So the first thing is that whatever the information that we have to transmit, it could be a speech, or it could be a data, or it could be a video. Whatever the information that you have to transmit is in the electrical form, and this information will be given to a driver circuit. Now, this whatever the information that we are transmit in the form of electrical signal, it will be given to a driver circuit before giving it to a light source. Light source could be your laser. So before giving it to a light source, we have to first give it to a driver circuit. Why? Because we have to adjust the current given to a light source. The amplitude or the magnitude of a current should not be high for the light source. It should be between a manageable range of a light source, so that it should not destroy the light source. That's why whatever the current, the information in the form of a signal or a current you are giving, it should be first given to a driver circuit. Driver circuit will maintain a safe level of a current before giving it to a light source. Once it has been given to a light source will convert whatever the electrical form of information into a optical form. Now, it is this transmitter, which is entire block of a transmitter responsible for converting a electrical signal into a optical signals. Now we are having a fiber flyhead. This fiber flyhead is basically a fiber that is attached with the laser source. So whatever the source that we are getting in the market, it is having a small fiber attached with it, and at the end of that fiber, there is a connector that is used, so that if anybody wants to use that source and convert the electrical energy into an optical form of energy, that optical form of energy should be easily coupled with the fiber. So in order to couple it properly with the fiber, there is a fiber flyhead which is attached inbuilt with the light source. So whatever the optical signal that will be emitted from the light source, it will be transmitted in the fiber flyhead, and at the end there is a connector. This connector is used to connect the optical energy with the medium. So here we are talking about the optical fiber medium. So this is basically entire thing is your optical fiber. So if you want to use a optical fiber for a communications, first of all, you have to convert electrical energy into a light energy. That is done by a transmitter. That transmitter, at the extreme end of a transmitter, you are having an optical signal that has to be transmitted. So before transmitting, giving it to a fiber, you have to connect some kind of a connectors. So that connector will connect one end of the light source with the other end of the optical fiber that you are using as the transmission medium. So this is connector is basically used if you are talking about, if you have the aim of establishing a communication with the help of fiber optics, temporary, not the permanent way. So that in that case, you are going to use the connector, so that once your aim is over, or once your purpose is over, you can remove that connectors and detach the transmitter from the optical medium. But in the case if you want to establish a optical fiber link permanently, then in that case you have to splice, you have to use the fiber splicing technique in order to completely fuse the one end of the fiber with the other end in order to establish a permanent link. But if you are concentrating on establishing a temporary link, then you have to use a connector, so that whenever you want, you can detach the medium. But in the case if you want to permanently use the optical fiber for communications, then the only option you are having is a splicing. So after splicing, if you want a permanent, then you use optical splicing. If you want temporary link, then use connectors. So once this is over, after that you are transmitting your optical information through a fiber. So there is a possibility that you want to divide your information into two parts. Some application require dividing of information into two different or sending of information into two different locations. So in that case, you can use another component which is called as a beam splitter. It's going to split the optical signal into two equal parts. So you can use a beam splitter for splitting the signals. So one of the signal you can use it in some way that you want as per the applications, and the another signal just passes out, the same signal will be passes out. So for if you are concentrating on the long haul communications, then obviously at a particular distance you have to use a regenerator, because due to several things like phenomena like attenuation, dispersions that is going on inside the fiber, the strength of the fiber decreases, or the different waves start overlapping each other. So in order to avoid that thing, you have to use a regenerator module, you have to use a regenerator box. That regenerator box itself involves various components. First is a optical receiver, so that you can convert a optical signal from a fiber into a electrical form. Once it has converted into electrical form, there are various electronic circuitry that can be used as an amplifier to amplify the strength to a safer level. And once you have regenerated your signal back, you have to again convert it into a optical signal so that it can be transmitted through a optical fiber. Now after this regenerator, you have regenerated your original signal back to its original level. So after that, again you are transmitting that information through a optical fiber. So before the receiver, if you require, then you can optical amplifier. Otherwise, if the distance is short, then you can avoid this optical amplifier before converting a optical signal into electrical form. So here there is a again fiber flyhead. Before fiber flyhead, you have a connectors. That connector is used for connecting a medium, that is optical fiber, with the input of the photodetector. That photodetector is responsible for converting a optical signal into a electrical form. So as we have already discussed that in the case of a light source, a fiber is attached internally with the light source, so that there is no problem of coupling a light inside the fiber. Similarly, there is a fiber flyhead attached with the optical or a photodetector. Now, after converting to electrical signals with the help of this photodetector, you can use an amplifier to gain or to get the signal to its original level. If there is a reduction in the strength of a signal, then you can recover back that strength with the help of a amplifier. Finally, once you have achieved a safe level of your amplitude of the signal, then after that you can restore the signal to its original form, and finally you will get an electrical signal that you have transmitted from the source. So these are all the different elements that when they are combined, they are forming a optical fiber links. So first is your electrical signal, whatever the signal in the form information in the form of electrical signal given to a transmitter. Transmitter will convert that electrical signal into a optical form. So that optical signals, if you want to establish a temporary link, you can use a connector. But if you want to establish a permanent link, then in that case you have to use a splicing technique for permanently connecting the two optical fiber ends. Now, after this, it will be transmitted to a medium, that is optical fiber link. And if in between that link, if you want somewhere that you want that your information should be divided into two parts, or level of the power should be divided into two parts, so that one part that can be used for monitoring and the another part can be used for sending the informations. So this can be done by a optical splitter, also called by a name optical coupler. So after that, the information can be, or if the strength of the signal, if you monitor that the strength of a signal has decreased, then you can use a module called as a regenerator to regenerate your signal to its original level. That regenerator also involves several elements: optical, that receiver, that is the photodetector. Obviously there will be a photodetector to convert the optical signal back to its electrical signal, and then amplifying it to a safer level, you can give it back to a source, that is a light source, that is a laser, convert a electrical signal back to its optical signal. Now this information, once had regenerated to its original level, can be again transmitted through the fiber optic link, and at the receiver and or the destination there will be a receiver that will convert the optical energy back to its electrical form, and that information can be received at the destination end. So this is the entire elements that can be used to form or to establish a fiber optic link. Now next is the advantage. What are the different advantages that because of which we are using optical fiber communication? First, definitely the first advantage is tremendous bandwidth. This bandwidth is the main point that is responsible for the optical fiber, that is the upper hand of optical fiber in comparison to its other wired medium, that is a very high bandwidth and the information carrying capacity. That means if the bandwidth is high, then obviously you can transmit more number of informations. So that is the first advantage. Second is your low transmission loss. So your fiber is having a very low transmission loss. Why? Because we know, we have understand the history of attenuations, that what are the different bands of optical bands that you can use to reduce the attenuation in a signal. So if you have reduced the attenuation in the signal while transmitting the signal through optical fiber to a level like 0.2 dB per kilometer, so definitely the loss will be very low. The third advantage is that it is highly secure, very secure, because there you are having a various layers that are formed, that is a core, then cladding, and then after the cladding you are having a various levels of coating, and finally you are having a jacket. So it's very difficult to tap the informations, as well as it is free from electromagnetic interference. So immune to static noise, immune to a crosstalk, and immune to environmental variations, because it is having a layers of a jacket that are formed around covering the core and the cladding. So it is very very immune to any variations that is going on across the that your fiber link. And even if it can be any strain, that is if we are putting any strain on the optical fiber link, it can easily bear that strain also. Third is that, and the second last is the reliability. This link is very reliable, because if something which is very secure, which can transmit the more number of informations, and which is and difficulty to tap the informations, so if it is meeting all these requirements, then definitely that is highly reliable. Something reliable means if you have this point in your back of your mind, that whatever the information that you are transmitting through optical fiber link cannot be tapped, or it cannot be that there cannot be some introduction of crosstalk or electromagnetic interference, then you are completely ensuring yourself that whatever the things that you are sending from a source, that will be definitely going to be received at the destination end. So it is highly reliable and easy to install and maintain. It's a very easy to install, as well as the maintenance is also very low for the optical fiber communication. Now these are the area of application of the optical fiber. What are the areas? First, we have already understood that communications, optical fiber are used in a communications because it is having a very high bandwidth, it is highly secure, more information can be transmitted as the bandwidth is very high. It is free from electromagnetic interference, immune to a static noise, as well as it is highly secure, highly reliable. So you can use it in the communication system. Similarly, it can be used in a medical equipments, like in the case of your endoscopy, you can use the fiber optics. Then fairy lights, you have everyone have seen that optical fiber concept is used in the various devices that can be seen in the market. That is fairing lights, various kind of lights that are used in the season of your Diwali also. Various optical fibers form of lighting are used. And the fourth case is your internet. If for high speed, for a high bandwidth and secure information, you can use it optical fiber. Then in the surgery and dentistry also, this optical fiber is very useful for establishing a computer networking, because this is for a higher bandwidth, higher security, you can use optical fiber. So it can be used in the computer networking. Apart from this, in the application of military applications, as this link is very secure, So it can be used in the military applications for where we require a highly secure link has to be established for transmitting information from one base to the another base. Similarly, in a space applications also, you can use your optic links or various sources of your optical fiber, various sources of optics, like you can use lasers, you can use optical fibers also, because it is immune to any environmental disturbances. So it can be used in space applications, and we all know that it can be used in cable televisions. So these are all the applications of your fiber optical links that you can use in your daily life. Now, the next thing is, what is the structure of a optical fiber? What are the various materials that when they are combined, they form a optical fiber? So basically, there are three components that are combined to form a structure of optical fiber. First is your core, then we are having a cladding, then after that the final part is your jacket. So in this core is made of materials, that is silica, that is a glass, and its refractive index is higher than the refractive index of a cladding, in order to ensure the total internal reflections. So the refractive index of a core is higher than the refractive index of a cladding. Also, to provide to increase the mechanical strength of this core, there is a cladding. Apart from this cladding, there is a surrounding coating that is used to provide a mechanical that provide immunity to any mechanical strain or a stress around this cladding. So this coating is used to provide it a good tensile strength. Apart from this, you are having a outer layer jacket. That outer layer jacket is also used to provide more strength, or to provide immunity to its environmental variations, because this, if any stress is just applied on this outer jacket, so it can bear that stress, or it can bear that any mechanical stress that is applied, and it's not going to provide any effect on the core and the cladding through which actual communication is going on. Actual communication is done inside a core to the help of internal reflections. So this is about the structure of a optical fiber. So in our next module, we are going to discuss about what is the basic phenomena, that is a total internal reflection, is skew ray, Madonna ray, numerical aperture. What is these concepts that are used in the optical fiber? So we will meet in our next lecture.